Hi guys, and welcome back to the ACE Academy. In this video, we will be looking at longitudinal pulses. Now, in this section of wave, sound and light, I explained that the fundamental concept is transferring energy without transferring matter. To say that in more detail, we are going to transfer the energy that is applied at one point to another point without transferring the matter from that point to the end point. Now, when it came to transverse pulses and transverse waves, we learned that the type of energy being applied was a disturbance in the medium that acted perpendicularly to the direction of motion of the pulse or wave itself. Where longitudinal pulses and longitudinal waves differ from this concept is we are now going to be applying this force in the same direction in which we want it to travel. So instead of it being applied perpendicularly to the direction of propagation of the pulse itself, it's going to be applied parallel to the direction of propagation of the pulse itself. In order for us to understand this concept fundamentally, we are going to have to ask ourselves a few questions. Firstly, we needed to ask ourselves, how would we define this type of pulse? And that is simply put as an isolated disturbance in a medium that acts parallel to the direction of propagation. I've just stated that for you guys. The next question we need to ask ourselves is, how is this pulse created? After we ask ourselves how a pulse is created and after we figured it out, we are going to need to understand what effect does this type of pulse have on the medium through which it is traveling. So let's go ahead and get started with understanding how this type of pulse is created. Now, the model we are going to use in order to understand this pulse is going to be a simple spring, because this is the type of model that suits this section perfectly. Now, the way in which I am representing the spring is as a series of parallel lines that are drawn vertically and are connected at their top ends and at their bottom ends. You can see that this diagram has a measure of distance at the bottom, each block being a single unit, and we are going to see how it affects this type of medium. Now, to get started, we are going to introduce some sort of disturbance to this medium. So I am going to look at the first line in this diagram, which is the red one right here, and I'm going to apply some sort of disturbance to move this red line from its initial position at 1 to a new position at half a unit away. So if I did that, we can move on to the second frame, and you can see that the red line, which was previously at a distance unit of 1, is now going to be at a distance unit of half. Let's look at what effect this has on the medium itself. We can see that the first red line and the first black line have become closer together. This distance right here is now half a unit instead of one whole unit like it was here. This shortening of distance between the lines themselves is what we call a compression. After applying this initial disturbance that moved the first particle a certain distance away from its initial position, we are now going to move this particle back to its initial position, which it was at rest. So we are going to move it back to the distance measurement of 1. That's its initial position. So let's move on to the third diagram to see how this is going to affect the medium. In the third diagram, you can clearly see that this red line has moved back to its initial position at 1. But hey, what happens to that initial force that we gave it that moved this red line to the half a unit line at first? This force is now going to be transferred to the first black line, and it's going to move that black line from its position at a distance measurement of 2 to a distance measurement of half, because that was the same amount of force that I gave to the first red line. But hey, what happens here? How is it affecting the medium? We can see that the distance between the first red line and the first black line has now increased. This increase in distance between the first red line and the first black line is what we call a rarefaction. Now, this type of movement or this type of disturbance is going to travel through this wave from left to right, where each one of these lines is going to move half a unit to the right, and then it's going to move back to its initial position. After it moves back to its initial position, the next line in the medium is going to move half a unit to the right, and then it's going to move back to its initial position, and it's going to create this type of cascading effect, transferring the energy from one line to the next. Let's have a look at it together. We can see that in the second frame that we had worked with, the compression was between the red line and the first black line. In this case, the compression is between the black line and the first green line. Let's look at the fourth frame in the motion of the pulse. We can see that after the black line was moved half a unit to the right from its original position, it's now moved back to its initial position, which was at 2, and the green line is now moved half a unit away from its original position, creating a rarefaction between the black line and the green line, where initially we had created a compression between the black line and the green line. Now there's a rarefaction. But hey, what happens to the relationship between the first red line and the first black line? It is now at equilibrium. It is now at rest. There is no more energy to transfer between the first red line and the first black line, because it already transferred the energy, the initial energy that moved the red line to the right and then moved it back to its initial position away from these two lines. So these two lines will now be at equilibrium, whereas we will get a rarefaction between the black line and the green line, and we are now going to get a compression between the green line and the black line that follows afterwards. We can see that the particles to the right of the black line, of this black line right here, are going to be at equilibrium. They're all 1 unit away from each other. This type of pattern is going to continue until this energy is dissipated and leaves the system of the medium. So looking at the fifth frame, we can see that the distance between the first red line and the first black line still remains at equilibrium, and the distance between the green line and the second black line, where previously was a compression, will now become a rarefaction, and the compression will now travel to the black line and the turquoise line. And of course, everything after the turquoise line will be at equilibrium as well. This pattern will continue repeatedly until the last black line and the last red line will be in compression. The black line will return to its initial rest position. The red line will move to the right in order to continue that transfer of energy, that initial disturbance that we had given the system. And once it does transfer that energy to the last red line, it will transfer that energy out of the system, and this red line right here will return to its equilibrium or to its rest position, and it will look identical to the first diagram that we had, where all the particles in this medium were at rest. So essentially, for a longitudinal pulse, it is going to transfer this energy through compressions and rarefactions, and as we can clearly see, the disturbance was applied in the same direction as the direction of the pulse, and hence it was applied parallel to the direction of the pulse. I want you guys to take note of one more thing before I end this video, and that is the fact that even though the particles moved left and right, the first red particle did not move to the last one, nor did the green particle move to the last one, nor did the turquoise particle move to the last position. They just vibrated in their relative positions half a unit to the right and then back to their original position. So the energy was transferred, and yet the matter, the particles themselves, were not transferred to the endpoint. That's it for me, guys. All the best, and I will see you in the next one.